Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the radius of common surface in merging of two soap bubbles. So this is a very commonly discussed topic of surface tension, and let us see the scenario that first of all, when these two bubbles which are of different radius initially coalesce with each other. Coalesce means they are merging with each other. Then obviously if we see the scenario, then there will be this diagram in which this is the smaller bubble, this is the bigger bubble, and when they are coalescing with each other, then there will be a common surface which is having some radius which is different from R1 and R2. Now obviously if we consider a small element dl at this point, then we can say that the material of these two bubbles is same, and therefore the surface tension acting on this point will be equal in all three directions. This is the surface tension force which will be equal in all three directions, and it would be 2T into dl, where dl is some element at this place. So if we measure this angle, this will be 120 degree, this will be again 120 degree, and this will be 120 degree, because we know that according to Lami's theorem, if three equal forces are acting at a single point and that point is in equilibrium under the effect of those equal forces, then obviously we can say that those forces will be acting at an angle of 120 degree with each other. Okay, so this is the initial discussion of the angle between these three forces, and now let us discuss about the radius of the common surface. Now you can also wonder why that this common surface will be inclined in such a way such that its concave side would be towards the center of the smaller bubble, because obviously if we write down the pressure at inside this smaller bubble, then pressure inside this smaller bubble will be P1, which would be equal to P naught plus 2T by, in fact 4T by R1. Okay, and the pressure inside the bigger bubble P2, so P2 will be equal to P naught plus 4T by R2. This is the pressure inside these two bubbles, and obviously we know that R1 is less than R2, therefore we can say that P1 will be greater than P2. So we always know that the concave side of any free surface of liquid has greater pressure. So the pressure at this side is greater than the pressure at this side, therefore the concave side of this surface will be facing towards this center. Okay, now let us see that if we imagine the difference of pressure on these two sides, so we can say that this is a surface which is having some radius r, so the excess pressure will be 4T by r, where r is the radius of this surface, and this excess pressure will be greater than the at this concave side, and it would be equal to the difference of the pressure between concave and convex side. So 4T by r will be equal to P1 minus P2. So 4T by r will be equal to P1 minus P2, and if you subtract the P1 and P2, then it would be 4T by R1 minus 4T by R2. So cancelling 4T with 4T, 1 by R will be equal to 1 by R1 minus 1 by R2. This will be the radius of the common surface, and we can say that R will be equal to R1 R2 upon R2 minus R1. This will be the radius of the common surface. Now we'll be discussing some more important concepts of surface tension in the next video. Thank you.